Once that's been done, we can then proceed to our marking interface. So we will open up the marker view, and now we can see our pattern pieces on the marker view. By default, the layout of the pattern pieces is going to be exactly what you see in the document view. So we have our pieces arranged there in the same fashion as what's in the document view. The marker interface is broken up into three main sections. At the top, we have our list of markers, and this is where we can make changes to our markers, including the material and the lay rules. Bottom left, we have our piece selections. So these are all the pieces that are on the marker. And from here, we can add or remove pieces to or from the marker, and we can also change the constraints placed on the pattern pieces on a per pattern piece basis. So we can either double click on the pieces to open up the editor or just click the edit button. On the right, we have the manual nesting interface. So this is where we see a preview of our material. So over here, we can drag and drop our pattern pieces. We can right click on them to rotate them to any orientation that we want within the constraints of the lay rule selected for the pieces. And we'll notice that as we drag our pieces, if we drag them off the bounds, they turn orange and it doesn't allow the rotation. Also, if we drag them over top of other pattern pieces, they turn red and they collide, and you're not allowed to do that. If your nest is very crowded and you just need to drop a piece at any time, regardless of whether it's colliding or off the pattern boundary, you can just press escape to drop the piece, and that will allow you to make clear room to allow you to nest your pieces manually. We do also support automatic nesting using the Fraunhofer nesting algorithm as part of our ExactFlat professional package. So we will talk about that in a little bit, but before we look at that, I want to talk about our marker list and the marker manager. So up here, we're going to select our marker from the marker list, and we're going to click the edit button to open up the marker manager. With the marker manager open, we have the ability to add new markers, or we can remove existing markers. And for each marker, we have different properties. We have our basic properties, including name and details. We have our lay rules, which include the lay rule applied to this particular material or marker. So lay rules are just named collections of pattern piece constraints. So they just adjust the default constraints applied to the pattern pieces for this entire marker. From here, we also have access to the piece gap. This is the minimum allowed distance between any two pattern pieces. So typically in a cutting system type, your cutting table operator is going to specify an overcut just to make sure that the pattern pieces are really good and cut out of the material. For tools like a blade cutter, like a wheel cutter, you typically need overcut just because of the way the cutting implement works. Wheel cutters go around corners nicely, but they need additional overcut to make sure that they fully cut all the way through the material, whereas a drag blade is very good for precise cuts, but they don't turn corners well. Lastly, we have the edge buffer. So depending on your material, it may have an unusable portion of material along the boundaries. So you may find that your material is always fraying on the edges, and as such, you can't actually use it for manufacturing or production. So you can specify an edge buffer to make sure that your pattern pieces are never going to be nested within that unusable portion of material. Our next tab is our placement groups. So this is more applicable for automatic nesting, specifically with our production manager software. So in a production manager environment, that particular tool allows you to import multiple nests from multiple parts into a single marker, and then with placement groups, you can choose how the pattern pieces from your different parts are nested together, whether you want to keep them grouped together by part or whether you want to allow them to mix all together in the same document. Our last tab is our material tab, and this is where we can change the dimensions of the material. This applies more to automatic nesting with ExactFlat Professional. And with automatic nesting, There's two different ways that Fraunhofer can represent the material. The first way is that Fraunhofer will represent the material as an unlimited roll of material, and this is useful for conveyor or continuous cut systems where you can generate one single long nest, and the cutting table will automatically pull additional material onto the cutting table surface as you are cutting your material. The other option is to use a bound surface, and this is useful for things like static cutting tables where you have to manually pull the material onto the cutting table surface, or if your material comes in a very defined stock size, such as a 4x8 sheet of material or a 2x2 sheet of material. In that case, you would use a bound surface where it has a very defined width and length, and Fraunhofer will nest onto one or more of those bound surfaces. From here, you can change your material dimensions. So if we are using bound surfaces, we can adjust the dimensions of the bound surface. So for this particular one, we have a very, very long bound surface. So you can independently change the length of your surface, the height of the surface, and the number of surfaces in stock. If you have an unlimited number of surfaces in stock, then just click unlimited here. Or if this is a static cutting table, click unlimited, and it will just create as many nests that are required to fit all of your pattern pieces onto the marker. If you have multiple surfaces in stock, then you can add multiple surfaces. So if I wanted to add, if you had a couple 2x2 sheets of material, you can add those, and then you can have the rest of your nests going on to the 4x4. You can add those materials there, and you can also adjust the priority and the use of the material, the ordering that they're going to be used. So there's a lot of options that you can set to define how your nest is going to be accomplished and in which order your bound surfaces are going to be used. If we are using unbound surfaces, then you can uncheck this, or if your material by default has been created as an unbound surface, then this would automatically be unchecked. And then we can modify the length of the material. For unbound surfaces, it's not possible to adjust the width of the material. So for this particular material, we are always going to be at 1.5 meters. However, we can adjust the maximum length, and this would depend on the roll length of your material. So even though it's an unlimited length marker, you might only have a little bit of material left on your roll, so you can adjust the maximum marker length to accommodate the length of the roll of your material. We'll go ahead, we'll click OK. We're going to leave this marker as an unbound surface. And so once your marker properties have been set, we can then move on to our pattern piece properties. So we're going to go ahead and click the edit button here, and this will bring up the pattern piece properties. We can adjust these properties on a per pattern piece basis, or if we want, we can select every single piece in the list and adjust these properties for every single piece simultaneously. For each piece, we can adjust the rotation increment and the rotation tolerance. The increment is the increment at which rotations occur. So for the default lay rule applied here, we picked anyway, which means that our pieces can rotate in any increment. However, if we have a very specific material like a stripe or a plaid, then we may only want to allow our pieces to rotate in 90-degree increments for a plaid to make sure our piece is always aligned to the plaid print, or we may only want to allow them to rotate in 180-degree increments. That way the pieces are always aligned to the stripe of the material. So we can do that by adjusting the rotation increment here. Set this to whatever you want. In my case, I'll change it to 90 degrees. And then if you want to allow a plus or minus variance from that 90-degree increment, then you can set a tolerance. So if I set a 2-degree tolerance, then it's going to allow me to rotate my pieces at 90 degrees plus or minus 2 degrees. So that gives me a 4-degree window of rotation. We can also adjust whether we want to mirror our pattern pieces or match the rotation of our pattern pieces by turning those on or off. If we turn mirroring on, and not only am I going to get a copy of my pattern pieces as seen in the marker view here, but I'm going to get a mirror copy of my pattern pieces. So if you design your part as only one half of a part, you can turn on the mirror option, and that will effectively mirror your pattern and give you both halves during the nesting process. The match rotation will enforce a constraint where every single copy of a pattern piece will have the exact same rotation. So if you want a very uniform run of product, you can turn that on to make sure that every single copy of your marker will have the exact same orientation of pattern piece with respect to the grain of the material. Parent multiple and mirror multiple adjust the multiplier for your piece count. So for parent multiple, if I wanted to add additional pattern pieces, right now I only have one copy of each pattern piece. Let's say I wanted to do a production run of 10, I can change my parent multiple to 10, and that will effectively add 10 copies of each pattern piece to my marker. Similarly, if I have mirror piece turned on, I will then be able to adjust the mirror multiple, and that will adjust the number of copies of mirrored pattern pieces that are on my marker. Allow flip and allow in X and Y enforce constraints of whether your pattern piece is allowed to flip itself in the X or Y orientation. So this is very similar to the mirror function. So if your material doesn't have a finished side and an unfinished side, if it's the same on both sides, such as a roll of cotton for something like a t-shirt, then you may want to allow your pattern piece to flip in the X or Y orientation, depending on which gives a more efficient nest. So you can turn those on or off if your material allows you to do that, and if you don't mind your pattern pieces to flip, depending on whether your material is printed or not, you might get a better nest with that. The last two options here are X and Y pattern offset. These aren't really used internally, so we don't recommend changing these. So just leave these at 0 for now, and once you set the rest of your pattern piece constraints, you can click OK. So after changing our grain orientation, our allowed rotation here, if we try to rotate our pattern piece, we're going to see that it is snapping to our grain line is snapping to our rotation increments here. And because we set a plus or minus 2-degree rotation increment, we can see there's a tiny bit of play in there with how it's being rotated. Also, because we adjusted our parent multiple, we can see over here, it's telling us what our multiple count is. And over here in the right-hand column remaining, we can see that we have 9 copies of our pattern piece remaining in inventory, ready to be added to the marker. As I mentioned previously, the default arrangement for the pieces on our marker is exactly as what we see in our pattern viewport. So if we are not using automatic nesting, then there are a couple options to adjust how our pattern pieces are automatically placed into the viewport. If you don't want them all stacked on one another, we can adjust the initial placement options, and we can do that for this marker only by clicking the cog icon down here, and this will open up the placement options. The default option of none will basically place your marker pieces exactly as you see them in the pattern viewport. We have a number of different options here. Box packing will attempt to perform a basic nest of the pattern pieces. So I'll select box packing. I'm going to close the placement options, and I'm going to click the repack marker button here. And when I do that, we can see our pattern pieces are automatically being rotated, and a basic nesting is being done to the pattern pieces to try and place them onto the marker. This piece up here failed to place because ExactFlat was not able to rotate this in any orientation that allowed it to fit onto the marker such that it did not go off the edge. For the initial placement here, it's only going to perform a rotation if the rotation is allowed within the constraints of the lay rule. So for that reason here, I can manually rotate my piece and I can drag it on and it will fit. But the automatic rotation is being done to try and produce a pattern piece that has a minimum height configuration. So that's why the placement for that piece failed. We'll look a bit more at that option as we explore the placement options here, but for now I just wanted to show the effects of the box packing. We have a couple other placement methods, including linear left to right. This will just array our pattern pieces across the bottom of the marker, or the middle, or the top, and that really depends on the linear placement alignment, whether that's set to bottom, top, or middle. We also have linear right to left, salvage left to right, and salvage right to left. These last four options aren't very useful in a normal nesting environment. However, these are here more to support the pool and spa industry. So in most cases, you would use either none or you would use box packing. Once our pieces have been placed on the marker, you can continue using your manual nesting tools, or we can proceed to automatic nesting. But we still have our pieces remaining in inventory over here. We still only have one copy of each pattern piece on the marker. To add the remaining pattern pieces to the marker, we simply select the pieces that we want to add, and we click the four arrow icons down here. And this will add all remaining pattern pieces to the marker for us. Again, because automatic rotation, we weren't able to place these pieces up here, but we can either do that through manual nesting, or we can just let Fraunhofer take over and add them to the marker for us. So I'm going to bring up the placement options one last time, and I want to talk about auto rotate on bulk placement. This option will attempt to rotate your pattern pieces automatically so they consume the least amount of height as possible. This helps to ensure that our pattern pieces will always be able to be placed onto the marker. The reason these pieces up here are failing to be placed on the marker is simply because the minimum rotation is a rotation increment that is not allowed by Fraunhofer due to the constraints of the pattern piece that we placed on it. We only allowed it to rotate 90-degree increments. So that's why the automatic placement is failing. Before we nest our pattern pieces here, we're going to actually go to our marker properties, and we're going to change the material properties here. We only have a 12-meter length of material here, so we might want to change this to something a little bit longer, just so we can fit all of our pieces onto the marker. So I'm just going to change this to 127 meters, and when we click OK, we can see that we have a much larger roll of material, which allowed most of our pieces to be placed on there. The only ones that aren't placed are these pieces up here, simply because the automatic rotation to a minimum height is violating the lay rule constraints. However, if we manually rotate these, we can actually place them on the marker, and Fraunhofer will be able to do that for us. So once your markers have been set up, and once your piece constraints have been set up, and you're ready to nest, we can then click the nest button down here, and this will open up the Fraunhofer automatic nesting interface. There's only two options here. There's target yield, and there's maximum runtime. Unless you're nesting squares in a perfect square, you're probably never going to reach target yield. This is basically how much of your material, or what percentage of available material is being used. So a typical target yield is going to be anywhere from 60 to 80%. Anything above that is really, really good and really efficient. But again, it's very unlikely that you're ever going to get to 100%. So in most cases, you typically just change the maximum runtime. So this is the amount of time in minutes that the nesting algorithm is going to run. And as it's running, it's always going to present you with the newest, best result as it comes up. So in most cases, you can get a really good, really efficient nest in a matter of a minute. But if you're working in a production environment, specifically if your material is very, very expensive, or if you're doing very large runs of parts, then you might want to set this to something larger, like a couple hours, just to make sure that you're getting the most efficient nest possible. So once your yield and max runtime have been set, just go ahead and click the nest button, and very quickly Fraunhofer is going to take over, and it's going to start arranging our pattern pieces automatically for us to fit them onto the marker as tightly as possible. So already after a few seconds, we can see that our yield is up to about 75%, so we have a much more efficient yield than what ExactFlat's box backer was able to produce. So nesting has finished, so we're going to go ahead and click the accept button here, and this is going to accept the automatic nest, and it's going to update our manual nest over here with the results of the automatic nester. So we'll go ahead and close that, and now we can see the results of Fraunhofer. At this point, nesting is complete, so we can now proceed to export our pattern to a DXF, and we do that by clicking the export button down here. So once we click the export button, we now see the export profile manager. And this is where you can pick the profile that you're going to be exporting to. ExactFlat provides a number of different profiles for different cutting table systems, including Onometrics, Eastman, and Gerber Cutworks. So you don't have to use our profiles. Using the database manager, you can create your own custom profiles. And really the only difference between the different profiles is the layer names and the color of the layers and the entities that are being exported. So an export profile basically describes which elements of your flat pattern are going to be placed onto the DXF, and it describes what layer those different elements are going onto and what the color of those different elements is going to be. So ultimately, when you import your DXF into your cutting table system, your cutting table is going to scan the DXF, and it's going to assign different tools such as your blade, your drag blade, or your wheel blade, or a pen tool. It's going to assign those different tools to the different layers in your DXF. So you want to make sure that your layer names are correct. That way your cutting table is going to correctly recognize all of the features of your DXF and cut it out exactly the way you want. So if we look at our Eastman profile here, for instance, this profile includes all of the annotation features. We have all of our hardware and our marking features. We have all of our notches. Our sew lines are being exported to the pen me layer, and our internal perimeters and our pattern perimeter are both being exported to the cut me layer. If we compare that to something like a Gerber Cutworks profile, we're not exporting as many entities. Notably, all of our annotation entities are not included in this profile, and the layer names are different. So our sew line is going to the pen layer, our internal perimeters and our pattern perimeter are going to the cut layer. And again, if we compare this to something like Onometrics, the layer names are even further different. Onometrics is kind of unique. It relies more on color to identify the different tool. So again, you want to make sure both the layer names and the colors are correct. Once you have finished selecting your profile, you can then click the export button, and this will create a DXF for you. It will ask you to choose a location to save your DXF, and then you can save your DXF, which you can then send to your cutting table. Once you have finished with your pattern, we can then close the marker interface, and we can proceed to create a drawing for your part.